Hello everyone, welcome to the Waves and Optics class. I am Irene May Specular. This day, I'm gonna show you my DIY laser Stirling engine generator reflection of light. First, let us discuss the theory. Light is known to behave in a very predictable manner. If a ray of light could be observed approaching and reflecting off a flat mirror, then the behavior of light as it reflects would follow a predictable law known as the law of reflection. The diagram below illustrates the reflection of light or the law of reflection. So, in the diagram, the ray of light approaching the mirror is known as the incident ray or the labeled I in the diagram. The ray of light that leaves the mirror known as the reflected ray or the labeled R in the diagram. At the point of incidence, where the ray strikes the mirror, a line can be drawn perpendicular to the surface of the mirror. This line is also known as the normal line or that was labeled N in the diagram. The normal line divides the angle between the incident ray and the reflected ray into two equal angles. The angle between the incident ray and the normal is known the angle incidence, and the angle between the reflected ray and the normal is known as the angle of reflection. These two angles are labeled with a Greek letter theta, accompanied by the subscript read as the theta I for angle of incidence and theta R for angle of reflection. The law of reflection states that when a ray of light reflects off a surface, the angle of incidence is equal to the angle of reflection. The reflection of light can be roughly categorized into two types of reflection. First, the specular reflection and diffuse reflection, as you can see in the figure 3. Specular reflection is defined as the light reflected from the smooth surface at the definite angle, whereas diffuse reflection is produced by a rough surface that tend to reflect light in all directions. Light reflects from a smooth surface at the same angle as it hits the surface. For the smooth surface, reflected light rays travel in the same direction. This is called specular reflection. For the rough surface, reflected rays scatter in all directions. This is called diffuse reflection. For the objectives, first, determine the relationship between the incident ray and the reflected ray of the laser specular reflection. Second, determine the angle between the incident ray and the reflected ray. Third, determine the distance and the size of the reflection of light. For the materials that we are going to use for our DIY laser Stirling engine generator, for the procedure, how to make a DIY laser Stirling engine generator of a specular reflection, you can watch and follow my procedure what I do. For the procedure on how to use the DIY laser Stirling engine generator of specular reflection, tape the push bottom of laser with double-sided tape and attach the battery clip to the battery. Second, estimate the incident ray of the laser specular reflection that it reaches the CD tape and it will bounce back the laser reflection. Measure the angle of the incident ray of the laser reflection at the CD tape and measure the reflection ray of the laser light at the other surface. When it changes the distance between the source of light or the laser, the surface or the object for the incident ray, measure the distance and size of the reflection ray. Then lastly, all the data was recorded. We conducted 3 trials, so let us discuss the data and gathering. The table, it shows the relationship between the distance and the size between the incident ray and the reflected ray of my DIY laser Stirling engine generator specular reflection. We have conducted 3 trials. From the data above, every trial that has an accurate distance from the source of light, which is the DIY Stirling engine generator, yet the angle between the incident ray and the reflected ray are equal in 90 degrees. When the angle of incidence is the angle between the incident ray and the normal where it approaches 90-degree angle. while the reflected ray also approaches a 90-degree angle with the normal. Thus, the angle between the incident ray and the reflected ray approaches 180 degrees. The angles are measured relative to the perpendicular to the surface at the point where the light ray strikes the surface. First trial, with 1 inch distance, when it strikes to the surface of CD tape, then it shows that the angle of the reflection equals the angle of incidence. It produces a size of 8 inches in the first circle, then 13 inches on the second level of circle of the reflected ray. While the second trial with a 2 inches distance, when it strikes the surface of CD tape, it shows the same angles between the incident ray and the reflected ray, but the size of laser specular reflection is 10 inches at the first circle, and the second one is 17 inches. However, in the third trial, that there is still the same angles between the incident ray and the reflected ray, yet the distance, we adjusted it into 3 inches from the source of light. And when it strikes the surface of CD tape, then the size of laser specular reflection produces 12 inches at the first level of circle, and the second one
22 inches.
that produces by the reflecting light. The incoming light wave is referred to an incident wave, and the wave that bounces away from the surface is termed by the reflected wave. It is important to note that the light is not separated into its component colors because it is not being bent or refracted, and all wavelengths are being reflected at equal angles. When the light waves are incident on a smooth, flat surface, they reflect away from the surface at the same angle as they arrive. For the conclusion and recommendation, based on the experiment, the angle of reflection, which is 90 degree, equals the angle of incident of 90 degree also, and the angle between the incident and the reflected rays approaches 180 degree, wherein the angles are measured relative to the perpendicular to the surface at the point where the incident ray and the reflected ray strikes the surface. I concluded that the reflection process inverts each wave back to front. The size of the laser specular reflection depends upon the distance of the light source and how far the waves have traveled to reach the surface of the CD tape. I have noted that it is the specular reflection because the light reflects from the smooth surface at the same angle as it hits the surface, and this smooth surface wherein the reflected light rays travel in the same direction. Therefore, as the distance of light source increases, then the size of the reflection of light increases also. Otherwise, as the distance of light source decreases, then the reflection of light will decreases. I would like to acknowledge my instructor, Mr. Sanan M. Patricio from the Natural Science Department Faculty in the College of Education for sharing his own expertise and knowledge as well as for his unending support to finish this project. Thank you for watching.